Get him!
Good morning. Today's date is Tuesday, April 26th. For the freshmen, it is a Wednesday. Lunch menu for the day: soft shell taco, pork burger sandwich, turkey and cheese.
They weren't here yesterday. Freshmen forget. No. It's a reminder for freshmen because they have the attention span of a gerbil.
That's a good reminder for everybody. If I showed up the next day, I would still
At 11 o'clock, varsity track, PreCalc food. At noon, varsity boys tennis at Pier. And at 1 o'clock, varsity and varsity track at Rapid City. Dance team tryouts are today at 3:15. And I'll add more to that as I progress through the announcements. No activities are taking place on Wednesday, April 27th. On Thursday, April 28th, varsity and junior varsity tennis at Rapid City, and then
Do the thing.
Fine Arts Gallery here at the high school gym. The Anime Club invites you to watch Spirited Away after school tonight. This will take place in the library. All students are welcome. This program won an Academy Award for Best Animated Feature. Juniors, makeup days for the South Dakota assessment will be held on Thursday and Friday of this week. If you missed either of the testing days, please see Mrs. Murphy or visit with Mrs. Lammers in the counseling office so that we can get you scheduled. Student art show going on right now at the Common Grounds. Also last week for the Community Art Show. Congratulations to Jaden Reiner for winning the People's Choice Award out of all the categories, including the professional artists. So Jaden, good job. Thank you. Anyone who wants to work on practice questions for the West River Math Contest, please see Mr. Spear over lunch on Tuesday and Wednesday. Tryouts for the competitive dance team will be held Wednesday, April 27th, after school. They are open to all current 8th to 11th grade young ladies. Potential dancers will need to attend one learning session, either on Sunday, April 24th, or on Monday, April 25th, which was yesterday. Attention juniors, any junior wishing to run for a student body officer position needs to pick up a nominating petition in the main office and get it turned in by the end of the business day on Monday, May 13th. Positions are of the following: president, vice president, secretary, and treasurer. And remember that student council is an activity, and you must maintain eligibility under the guidelines of the South Dakota High School Activities Association in order for you to attain a position. If you have any questions, please see Mr. Gainey or Mrs. Applin. The election will be Tuesday and Wednesday, May 14th and 15th, via our mobile platform. Spearfish High School Fine Arts Booster Club is hosting the annual Fine Arts Gala on Thursday, April 28th. This will take place from 6:30 to 8:30 in the high school gym. The next meeting for the National Honor Society is April 27th during lunch in Mrs. Whitenberg's room. All members are required to attend. Please bring in your service hours form. The Spartan Athletic Booster Club scholarships are now available. This is a $1,500 scholarship provided to 2 senior male athletes and 2 senior female athletes. And finally, Dickinson State University representative will be here today during lunch. If you are interested in learning more about Dickinson State University, please stop by and see them. May I please have you stand for the pledge. Pledge allegiance to the flag of the United States of America. Lengthy number of announcements and meetings and reviews. Please see the high school website or stop by the guidance office or the main office. Thank you and have a great day.
And remember your rules, what the domain and range of each are, what quadrants you looking in, is it a legal target? Thank you. Should be relatively quick. Anyone still rolling? Hearing no objections, the motion passes. Okay, cosine of 5 pi over 2, is it legal? I can take cosine of whatever I feel like. So, cosine of 5 pi over 2, you're going to have to go to the coterminal angle, right? I'm going to have to go 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. I look at the cosine value, which is the x part of the coordinate, and it'd be 0. So this is now the arc cosine of 0. Arc cosine is 0 a legal target? Between -1 and 1, it's good. So I look in what two quadrants? 1 and 2. And in 1 and 2, up here at pi over 2, I get my value. Make sure that it's pi over 2. Don't just say 5 pi over 2. Arctangent of -5 pi over 2. Oh, green. There's 1, 2, 3, 4, 5, -5 pi over 2. I go to take the arctangent of -5 pi over 2, and it's a undefined. So if I try to do the arctangent of undefined, ew, that's gross. You just can't do it, right? Now I know you might want to say, well, where is the tangent undefined? It's at pi over 2 or -pi over 2. But I can't put undefined in as a value. I can't say find f of blue. Like, that's not a valid input. So, undefined. Can't do it. And then the last one is not on my unit circle. Arc cosine 4/5 is a legal target. Yep, anywhere between -1 and 1. It is not. What two quadrants am I looking at?
1 and 2.
Okay, and it's a positive 4/5, which is not one of my special values on the triangle. So I have to make my arbitrary triangle, use Pythagorean to find the missing angle, and now arc cosine of 4/5 gets me theta. Now go take the sine of theta, opposite over hypotenuse, 3/5. Okay. So, I know we started into law of sines yesterday, but felt this was more important as a gut check. Did you get it? Did you get it? Did you get it? And then in all this stuff, hopefully you were showing something to back it up, because naturally that's going to be wrong if you domino effect into it. I would assume I could say those, and then just if you got all 6 wrong, you deserve the 0. Don't go negative. But I know some of us didn't write any of that out at all because we were just looking at them on the circle. So I'm going to say 3 for the answers and 2 for the whoopsie before the answers. Okay? Because they were all 2-part, 2-stage. Anything about it? Because the remind scene has been pretty quiet the last few weeks. I mean, that's good if we're getting it. Normally, Chapter 4 is one of the ones that kids freak out about the most, but if you all are doing good, yay, and double yay, because this is the stuff you need to know to be moving on to trig. Anything from 4-6, we had about 4 or 5 problems there. They're mostly just look it up on the circle, but anything from 4-6? How about 4-7? I think I only had, what, 2 problems there?
How do we draw the picture?
Okay. How draw a thing? Number what?
7.
Okay. Now, it doesn't say what direction you're in, right? It doesn't say north, south, east, west. Nah. Anything like that. So you get to putt in whatever direction you want. So we'll say stick figure Steve is here. They miss a 12-foot putt. So, I'll just say from him to the hole is 12 foot. 3 degrees off course. So stick figure Steve is actually going to putt this way. And this will be 3 degrees. I don't know how far. The hole now lies at a 129-degree angle between the ball and its spot before the putt. So they're saying that this angle right here is 129. What distance does the golfer need to putt in order to make the shot? Which, if I was looking really quickly, I think that was right here. Yeah. There you go. And then just do your law of sines. I do 3 plus 129 is 132. 132 away from 180 is 48 degrees. I've got my control pair. So sine of 48 over 12 foot is sine of 3 over x. Jesus fish your way through it and you're good to go. So the number one thing that physics kids come back to me and ask questions about is how do I draw this stuff out? Because you start getting questions like, plane was traveling 15 degrees east of north for this many miles. At this point, it course corrected to 23 degrees west of north. If it then has to return flight back and it's so many degrees east of south, what is the length of the last leg of the trip? You're like, what the, huh? If it says east of north, right? Never eat soggy waffles. So go east from north. They're saying this way, and my angle is going to be here. Okay, so being able to draw it out is, well, depends on how much practice you've had with cardinal directions and drawing things out. That's the old geometry axiom. When in doubt, draw it out. And there's nothing wrong with just a picture of the problem, a picture of what you got drawn, send it to me. Is this right? That's all it takes. That little bit of clarification is the difference. So, besides ew words, nothing? Okay. Then, we did law of signs, we did some law of signs, we did some law of signs. All right. The ambiguous case. Here's the thing. No, that's bigger. More of you can see it. Who here is into construction tech? Welding? Anything like that? Okay. Now imagine these are fixed lengths, right? This will not magically change length, even though it is wizard staff. This will not magically change length. This is a meter stick. It will not magically change length. If I try to make a triangle with these, I'm about to invade your personal space. Okay? Right now, I make triangle, right? Let's say I were to weld that in place. That angle is stuck. That angle will not move. But this angle is not. It's only this length and this length that are fixed, and that angle is welded into place. These are not. These can move. Is this the only triangle I can make? I can make another triangle out of it, can't I? So right now, I have welded into place, angle, a fixed object, side, a fixed object, side. Turns out I can't have an angle side-side congruence theorem in geometry because this might actually be in this direction. There are two possible triangles. Even further, what if I had this side length and this side length, and that's welded into place right now? Doesn't even make a triangle, right? It's just dangling there. Insert sophomoric reference here. So you get this idea that angle side-side was never one of my congruence theorems because we call it the ambiguous case, meaning I literally don't have enough information to confirm that it's this kind of triangle because there were more than one ways that this could have happened. And that's what all this is. They're showing us that, all right, you can do basically a quick Pythagorean theorem on it, and then whether A is bigger than B or B is bigger than A and all that kind of stuff. I don't worry about this. Instead, I'm going to say, if you try to do it in the calculator and it doesn't work and it tells you error, the triangle is not possible. But if it gives you an answer, there might have been two answers with it. And that is the ambiguous case. So we're going to start with one or no solution before moving on to the two triangle stuff. Okay? I put that word problem in there because this is where we were headed. They're not going to just give you a triangle because you're not sure there even is one. They're just going to give you information, and you have to draw arbitrary triangle and figure stuff out. So, find all solutions if possible. Notice the directions say to the nearest degree. Screw that. 3 places. Okay. They give me AC and angle A. So I need to draw arbitrary triangle, and they might not be to scale, and that's okay. Little a is 15, little c is 12. I don't know angle C, I don't know angle B, I don't know little b. And they say, go solve the triangle if you can. So step one to doing the law of sines is, do I have a control pair? I've got an angle and the side across from it. So I'm good to go to start the law of sines. I'm trying to find this angle. Why am I trying to find C first instead of B? I got nothing with B. There's nothing to compare the proportion to. So I start with my law of sines and say the sine of 94 over 15 is the sine of C over 12. Do your Jesus fish thing, alpha, and say multiply the two that line up, divide by the one that doesn't, the snack that smiles back, and I get sine of C is 15 sine of 94 over, or sorry, 12 sine of 94. Divided by 15. What mode should I be in? I got degrees in my information, I should be in degrees. Always double check it. Every time you reset that calculator, it goes back to radians. So 12 times sine 94, divided by 15, what you got?
11.97. Oh no, I missed that. That's what I got too. Yeah.
0.79 something.
I got 0.79. Yeah, I got 0.798.
In degrees?
Yeah, I got 0.798.
Did you close the parentheses on the 94 before dividing by 15?
No.
Okay. Little things like that, just, as an input thing, a technical matter. Y'all, look at what you just said, though. 0.097-ish? Oh, 798. Look at what you just said. You said the sine of angle C was itty-bitty decimal. Well, I can't divide by sine, but what can I do to undo sine? Arc functions. Remember, I'm trying to find an angle. If I'm trying to find an angle, I need arc sine. Back here, if I do arc sine of this, I get C. Arc sine of this. So with your calculatron, I got to go over to degrees. Degrees, I quit. Okay, alpha y equals thing, 12 sine 94 close over 15. Okay, I get itty bitty decimal. So I can do the arc sine of 3 ways to do this. Option 1, arc sine of, go highlight that and dump it in. It's going to be pretty accurate. Option 2, I do arc sine of, I can highlight the calculation itself, and it'll dump the whole thing in for me. Option 3, I could have just typed this to begin with. Okay? So if you're trying to find an angle, you're going to use an arc function. And the difference between getting little bitty decimals because I didn't do arc function and getting little bitty decimals because I'm in radians are two different problems. What's up?
There's a fourth option. You can just do a second negative and dip and make it change.
If you do second, you just
Oh, yeah.
Internally, it's the same.
Oh, that was the third one I was going to say, but then it was right here. And I forgot literally in the 30 seconds that I was talking. ADHD, go wee! So, this is a case where I do all the stuff and I end up with, I actually got one of my answers. I got the measure of angle C was about 52 point what? 944. And that's exactly how I'll write my stuff out too. Is next to this, I would have said measure of angle C is arc sine of 12 sine 94 over 15. Okay, because just like yesterday, we said little a was always b sine of a over sine of b, where b is my control pair. I'm also going to have the measure of angle a is, forgot my arc sine of b sine of it. No. Back that up. B sine of b. Why am I screwing this up so bad? It's right there in front of me. B sine A, because I'm trying to find the wrong angle. Sorry about that. I'm trying to find that. So the little thing goes right there. A sine B over little b. You ever spell a word and it doesn't matter what you do, it's wrong, and the more you try to spell the word, the more it doesn't look like a word anymore? That just happened, but with math. Okay. If I have that angle, how can I finish it? How can I still solve? I ain't done. Okay. So up here, I would say measure of angle B is 180 minus that stuff. And I can even write them in stages where I'd say 94 plus answer. Because if I do that, again, the calculation is staying in here. I'm getting the perfect decimal answer. 94 plus my answer. Okay? I forgot to close my parenthesis, but it still works. So that was 33.056. I still ain't done.
Now you have to find little b.
Now we go find little b, and I can set up my law of sines again. I'd have sine of 94 over 15 is the sine of whatever that answer was over little b. So I can say little b is 15 sine of that answer over sine of 94. Okay. It fits the proportion. If you need to write this part out, write it. If you're cool with these calculator shortcuts, write that instead. All right? I don't care which way you do it. Depends how comfortable you are with it.
So with that, how did you know that percent A was the largest
But it's 94. I just made a 94-degree angle. And I know it's the biggest one because I can't have anything bigger than 94, or else it's not a triangle. Okay? Now it does say the ambiguous case, one or no solutions. I started solving this and everything worked out nicely. Draw arbitrary triangle where A is 61. So I'm going to kind of weld that in place. I don't know how far out this goes, so I'll just make arbitrary triangle with A 61 degrees, 9. B is 11, so I'll just put my 11 here and my big B here. I like finding the one in that corner. If I just do it that way every time, it works out nicely. Do I have a control pair? That's a 9, not an A. I got my control pair. I set up law of sines. The sine of 61 over 9 is the sine of B over 11. I cross multiply. Multiply the two that line up. Divide by the one that doesn't. That's going to get me the sine of B. I don't want the sine of B, I want B itself. So the measure of angle B is the arc sine of Jesus fish. 11 sine of 61 over 9. So I go to my handy dandy calculator and say the arc sine of a fraction 11 sine of 61, close it, over 9. And this is why I said I'm not too worried about all that do the Pythagorean if A is greater than or less than B kind of stuff from the previous slide. I don't care about all that because if it's not a triangle, they're just going to tell me, no, you can't do that. I set up all of my math correctly. I went to go solve for this, and it turns out that's not a triangle. It doesn't actually look like this. It looks like that with 11 and 9. It's not big enough. That 61 welds it in place so that it's just sitting there dangling, never connecting to make a triangle. Okay? This is a measurement I know. It's welded in place. It's locked in. This is a length that I know. This is a length that I know. This is a little hinge, and it's just waiting to see, is it going to hit or not? Does it hit in one place, no places, two places? And it just doesn't, because when I try to do my law of sines over here, I get there is no triangle. I can't solve a triangle that isn't actually a triangle. Okay? So that's the two you got. One of them will work out all the way through. The other one will probably be a no solution. You know what? Maybe you even end up with a right triangle. If you do, then you can go do right triangle trig on it. So just draw your arbitrary triangle, start trying to solve it, and see what happens. Do you get an answer and everything's golden? Do you get 90 and it's a perfect 90 right triangle? Or does your calculator tell you what to go do with yourself? Now, drawing the triangle isn't actually necessary to solve. But a lot of kids, they're not going to want to do it if they don't physically see it in front of them. It just helps you know who goes with what. Visual representation. Okay. That's the stuff I know. That angle is welded into place. I know two side lengths. What I don't know is this angle and this side, or this angle. So those are all parts that can move, that can get bigger or smaller. I've got a control pair. Sine of 61 over 8 is sine of A over 12. I say the measure of angle A is arc sine, because I'm finding an angle, of 12 times sine of 61 divided by 8. Square root of 3 over 2. 12 square root of 3 over 16. 3/4 square root of, yeah, that works, right? Arc sine of 12/61/8. 12 sine of 61 over 8. Womp. And it tells me, womp womp, you can't do that. So it turns out there is no triangle. I go to contestant 2. A is 30. Little a is 13. Little c is 26. And someone's going to wonder, well, why are you drawing it like a right triangle? Because I know it's going to be a right triangle. Okay. Now, you're still going to do the process. I still have my control pair. I still have this angle, this side welded into place. It's set up the exact same way, but this time, when I do sine of 30 over 13 is sine of c over 26. What's the sine of 30? Boo. I'll make you do that quiz again. 1/2. So when I multiply 26 times 1/2 and then divide it by 1/2, I get the sine of c is 1. Where is the sine of c 1? at pi over 2 or 90 degrees. Now to solve the rest of the triangle, you're not going to use law of sines anymore because it's a 30, 60, 90 triangle. So now I'm going to use my ratios to finish it off. If that's a 90 and that's a 30, subtract from 180, I get this is a 60. To go from the hypotenuse to the short leg, I divide by 2, correct. To go from the short leg to the long leg, do you remember what we do? Multiply by square root of 3. So I want 13 square root of 3 there instead of ugly decimal. 13 square root of 3 says I recognize that this is my special triangle. I will solve it like my special triangle. Okay, like you meet family members and they give you the whole, oh, I haven't seen you since you were this big. But you recognize they're the rich aunt, so you're still going to be nice to them. Okay? I recognize that this triangle was special. I will treat it special. Because then I get in the will. Right? So in these cases, everything either worked out great, finish off the triangle, or it didn't work at all and I was able to just quit and say no triangle. The 2 solution case, that's the weird ones. Okay. Solve a triangle, or more than a triangle, that's got this information. So again, I set up arbitrary triangle with angle A is 43 degrees, A across from it is 25, B is 28, and B and C. And I don't know little c. Okay. Again, this angle is locked into place. This side is locked into place. This side is locked into place. But this can hinge right now because I don't know the length of C yet. Do I have a control pair? So if I got a control pair, start trying to find B. And say the measure of angle B is arcsine of, again, if you need to write it out, sine of 43 over 25 equals sine of B over 28, Jesus fish, arcsine. Okay? So I'm going to have 28 sine of 43 over 25. So quit. Arcsine of 28 sine of 43, close. Downtown 25 over close, bonk. And I just get an angle. You're like, oh, cool, I can just finish a triangle. And you're not wrong. 49.804. So now I can come all the way back here and say the measure of angle C is 180 minus 43 plus whatever I just got, right? Well, 180 minus, parenthesis, 43 plus answer. And if I keep using that feature, it's going to keep the whole calculation in there. So I'll have the perfect decimal train. Okay, 87.196. Am I done? Still got to go find little c. Sine of 43 over 25 is sine of 87 and change over little c. So I can say little c is 25 sine of what I just got, so I'll call that answer 2, over sine of 43. (25) sine of my answer over sine of 43. Womp. 36 and change. Before I go any further, check the answers that we got for reasonableness. Do they fit the triangle sum theorem? All angles add up to 180. Are they proportional? Biggest angle across from biggest side, smallest angle across from smallest side. Now, my triangle isn't drawn proportionally, but that's okay. I just needed to wrap my head around this. But there's a catch. There's a catch. Because yet again, you had down in this corner 43 locked into place. You had the 25 and 28. Couldn't this have swung over this way? How do you think you're going to get that angle? This angle down there and this angle right here. We don't need to swap anything. Has to deal with linear pairs from way back when. Because this bottom side here is a line. Do you add up to 180? Remember, linear pairs are two angles that make a line. The angles that make a line is 180, have to be supplementary. So way back here, when I got this, because it worked, and because of this particular angle, I know there's a whole other triangle where this is still 43, this is still 25, this is still 28, this is still A, B, and C. But this was the other triangle that was possible. And the way that I find it is very simple. When I got this answer, I would take 180 minus that answer to get its supplement, to get the other possible angle. And the reason for that, look at what function I just used. Arc sine. Where is arc sine restricted to? 1 and 4. Can you have an angle that is more than 90? So when I'm back there in that portion of the circle, it gave me a triangle that had a reference angle of 49 and change. The reference angle was 49 and change because it's in quadrant 2. My calculator is not going to give me the 130.01 or 96 or whatever it is. They're not going to give me that angle because arc sine isn't in quadrant 2. Arc sine will never give me an obtuse angle. I can have obtuse angles in triangles. So this is fundamentally flawed in that it can't give me obtuse angles. And I have to remember that obtuse angles are also possible. I take 180 minus all that junk, get the measure of angle B is about 130.1 196. Okay. There was another triangle possible. And then you just keep going. Solve that one. I had 180 minus that answer. Come on, you. I get 130 and stuff. I add that onto my original 43 and subtract from 180. I get the measure of angle C is about itty bitty little 6.804. It was tiny.
So we subtract, so like the angle C of the first one, we subtract that from the B to find the second one? Or
Whatever you got for your very first angle,
okay,
you're going to use that and 43 to find your first angle C. You're going to subtract it from 180 to find Darth B, its evil twin. Okay? Because there's two possible triangles because arcsine does not work in second quadrant. I have to remember that there was an angle in first and second quadrant that had the exact same sine value. And then go and find little c down here. My 6-point blah, 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 blah. I'm going to do the sine of 43 over 25 as the sine of 6-point junk over c. Get little c is 25 sine of whatever that was. My fourth answer now? What? 1, 2, 3, 4, 5. Over sine of 43. So I got 25 sine of that nastiness over sine of 43. That's why I always draw mine this way. Because if I always draw it that way, then the hinge is always at the top. Because otherwise, my God, if this thing is like sideways or whatever, it messes with us. Because they gave me A and B. So C is the unknown side. C could have been nice and long, or C could have been really small. Because of that hinge. Okay, 4.343. That is not very big. So, before we go on to the next two, A, I'm going to do it again because I know you need to see it again. B, I want you to write down some notes for when this happens. Okay, so back here, this is the book. This was all formulaic. This was if A and B are greater or less than, do Pythagorean, find H, blah, 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 blah. Somewhere, find a spot to write. Maybe you had room back here, I don't know. The rules. When I have angle side side, it's a pain in the angle side side. It all depends on the given information. If I start with an obtuse angle, if I'm given an obtuse angle, you're good. There's one triangle possible. Because when I go to do arcsine, I'm never going to get what should have been an obtuse angle because I can't have more than one obtuse angle in a triangle. If it's a big ass, you know what you're getting into. But If it's a cute ass, you're in trouble. Because now, if I'm given an acute angle and I go to do the law of sines, one of three things is going to happen. Either A, it'll say not possible. There's no triangle possible. Like, I will go to do the law of sines and it will tell me error. This is not possible. Option B, when I do the law of sines, it's going to come out as a right triangle. So there is one triangle possible. Because if I tried to take 180 minus 90, I would just get 90 again. I'd get the same thing again. Or I'm given an acute angle with angle side side. I go to do law of sines and I get an answer. Then there's two triangles. The answer I was given, and then do 180 minus the answer. This is why you never had angle side side as a congruence theorem. Because arc sine does not work in quadrant 2. Arc sine will never give me an obtuse angle. But the angle might have been obtuse. Okay? That analogy brought to you by Mr. Devon Larson, courtesy of geometry in 1999. My old geometry teacher. He said, if it's the right ass, then it's the one. There's one triangle possible. If it's a big ass, you know what you're getting into. There's only one triangle. But if it's a cute ass, there might have been no triangle at all. There might have been two triangles. You might be friend zoned. They might already be with someone. So, that's your decision chart. I'll show you again. Start with draw arbitrary acute triangle. It does not have to be drawn to proportion. I'm just trying to wrap my head around it. Use the information you're given. Angle A is 38 degrees, little a across from it is 8. That's my control pair. I'm given B is 10. So if I want to draw my triangle the same way every time, where should I put B? If I want this to stay my hinge so I can just keep bringing this back and forth, I'll put it there. That means this is angle B, angle C, little c. Draw arbitrary triangle with the information you're given. Step 2. Go use the law of sines to try to find angle B. Measure of angle B is arc sine of, again, if you need to write it out, sine of 38 over 8 is sine of B over 10. Jesus fish, arc sine. Or you can just write 10 sine of 38 over 8. Okay, if you need to write it out, write it out. If you don't, don't. Because this is what my keys usually look like. Because it follows that calculator shortcut. So I go to do that. Uh-oh. Angle, side, side. And it was cute. I'm in trouble. There might be no triangle. There might be a right triangle. There might be two triangles. So whatever happens here determines which of those three outcomes it is. I head to my calculator. I do the arc sine of. a thing, 10 sine of 30, no, 38, close it, over 8, over, close it, done. And I get an answer. It had an acute angle side-side. They gave me an answer. There might be someone else anyway. There were two triangles. Okay? There were two possible triangles. So I am going to write this one 50.319, so, or 315, okay, 316. I got an answer that, and it wasn't 90. That means there's a second triangle possible because 50 degrees is over here. What in quadrant 2 has a reference angle of 50 degrees? Y'all hurting me. Here's 50 degrees. What angle over here also has a reference angle of 50? How do I find reference angles? I'm going to make you take the last two quizzes over again. How do you find a reference angle? 3 pi over 4? What you talking about? I mean, it's close to it, but that ain't 45 degrees, it's 50. How do I find a reference angle? 180 minus. Yo. 180 minus 50. 50 degrees, ballpark, is what it gave me. It could have been 130, but my calculator will never tell me something in that quadrant. So I have to be smarter than the calculator because I know that. I'm going to now make my arbitrary second triangle with 38 degrees, 8, 10, A, B, C, little c. I'm going to make this second triangle where I subtract from 180 to say that it could have also been 129 and change. That was its evil twin, its doppelganger, Spider-Man meme, pointing at each other. Okay? This could have been 129,684. I saw angle side side. It was an acute angle. I'm wary. I'm looking out. Something might go wrong. I do the law of sines. It did not tell me to quit. I know there's at least one triangle. It was not a right angle. I know there's two triangles because it gave me another acute answer. Go find the doppelganger, the evil twin, the other possibility, and now solve both triangles. Finish both triangles off. How do I find both of those angle C's? 38, 50 and change, subtract from 180. 38, 129 and change, subtract from 180. Go find your other two angles. The measure of angle C is 180 minus 38 plus about 50.316. Again, I'm going to use the answer button in my calculator, or I'm going to highlight that to drop it down. $180 minus 38 plus that 50 something. Told you they're not drawn to scale. 91,684. I'm also going to have 180 minus 38 plus 129 and change, and get measure of angle C is about 12.316. I subtract from 180 to find the two missing angles. Now go find the two missing bottom C's. Use your law of sines again. To find this little C, here's my control pair. That's what I'm trying to find. Sine of 38 over 8 is sine of that mess. I will use the repeat highlighter answer feature again. 91.684 over little c. Over here, I've got my control pair. I'm trying to find little c. Sine of 38 over 8 is sine of whatever I just got. I'll use the calculator to make myself accurate. 12.316 over little c. You can write them like that, or you can use the calculator shortcut and say c is 8 sine of answer over sine of 38. And say c is 8 sine of answer over sine of 38. Now, whenever you use that answer button, remember that's going to use whatever your last answer was. So you might have to go up and highlight the value instead. Because if you just hit answer every time, it always uses whatever your last answer was. Okay? So the 12 and change was my most recent answer. I'm going to do that one first. 8 sine of whatever I just got over sine of 38. Itty bitty living space. I get this guy is about 2.772. Over here, it's going to be 8 sine of 91 and change over sine of 38. So 8 sine of 91 and change divided by sine of 38. $12 and change. Okay. 12.989. Another reason that I don't write out these parts is because of how cluttered this gets. There's too much stuff going on. Okay. Now it's going to happen this way every time. In fact, I can set up kind of an algorithmic space for it where I have my triangle A, B, C, my triangle A, B, C, where I say that this is arcsine of, it's going to be little a sine of, or little b, there we go, sine of a over little a. I can set that up formulaically. Say that's answer 1. I can say that this is 180 minus answer 1, because I'll subtract to find that angle. I will also use this answer 1 to go find this guy. I'll say measure of angle C is 180 minus angle A plus answer 1. This gave me answer 2. I can write that up there as well. Measure of angle C is 180 minus angle A plus answer 2. I can set this thing up algorithmically knowing that this is now answer 3, answer 4. I can set up my little c down here using my control pair. Is going to be A sine of answer 3 over sine of A. And say this little c is going to be A sine of answer 4 over sine of A. Your two triangles will always end up like this. Every single time. You can literally just fill in the blank. Press buttons on a calculator, fill in the blank, because it will come out this way every time. Okay? Hint, hint. Test Friday. Hint. So, let's try it. You know what? Get rid of the 65, 57, and 55. That's ready to go. That's how it's going to be set up every time. You start off with a different color. All right. I have a control pair, 65 and 55. I can go find arcsign of stuff. That stuff is, you remember? You should have it on your paper right in front of you. Sine of 65 over 55.
57 over 65.
Okay. I dump it in my calculator. What do I get? There's answer 1. I'm going to use it both here and here. I'm going to use it along with 65 to go find my other angle C in the first triangle. Anyone else? I see 1 bobble, 2 bobbles, 3. Okay. And then I can use that angle down here, sine of, oh, I put that in a box in the wrong spot. To say 55 sine of whatever I just got over sine of 65.
42.965.
Now, once we start getting to that thousandths place, depending how you're getting these, if you're highlighting a value, if you're typing it into 3 places, if you're using the answer feature, that thousandth spot might start to wiggle a little bit. But that's okay. That's why we're going to 3 places. Back here, 180 minus that stuff is what? 110 point? Take 110.072. Add it onto my 65. Take those away from 180. And again, I put that in the wrong spot. There we go. Plug that 4-point Frank. Come on. 928 down here. I'm still using 55 sine of 65. Getting little c.
5.213.
These are the answers. Finding those 6 pieces of information. But do you see how this is going to domino effect real hard? What happens if you're in radians when you go to find angle B the first time? The whole thing craps out. This is probably the most domino effect style problem you'll do in the class, where you really have to do that first thing correctly, or it's all toast after that. You see all of the expressions. You see me writing the calculator shortcuts up there using the law of sines. That's why we have the 3 decimal place value policy. Because I had kids, this is from geometry. I taught this in geometry. I had kids who just, you're talking about freshmen and sophomores who have never been in Algebra 2, they've never done anything else, and this was the first time that they'd seen anything like this, and here you go, kid. It was easier to just go to 3 decimal places, okay? Do we need another one of those, though? Like, do we get it? I don't care if you like it. Can you do it? As long as you got the notes and you can follow through, this goes here, that goes there, that goes there. Okay? And you've got that little bulleted chart written out of if it's acute, if it's obtuse. This is what it does, this is what it does. Okay? Now look back through everything we've done, though. Law of sines with angle, angle, side, no problem. Law of sines with angle, side, angle, no problem. But as soon as we had angle, side, side, it was a problem. Okay, that's why we didn't have that as a congruence theorem in geometry. All right, law of cosines. I'll leave for tomorrow. We'll finish off 4-7 tomorrow. That's gonna mess with stuff. I might monkey with the calendar. If 4-7 took us 2.5 days, I might move the quiz back to Thursday instead. I might do the quiz Thursday so that it's a clean break between chapters 4 and 6. Well, 6-1 is definitely a 2-day lesson. Depending on kids, sometimes 3.